Hello everyone. Hey, quick note before we get started on this lesson. I know these videos have been pretty long, and so I want to let you know, if you open up any of these instructional videos I'm doing, if you open them up on YouTube, the YouTube app, or open up a tab in YouTube, I'm going to segment the video. So down at the bottom on the timeline, I'm going to put little segments into the timeline that will allow you to jump forward to any problem, skip back to any problem, and hopefully, I know these videos are pretty long, so hopefully that will help you just kind of navigate the video. I know how it is. You're probably not going to sit here and watch every single second of what I say, so hopefully that helps you jump forward, jump backwards, find what you need to find. So today we're going to talk about conditions today. You know, everybody, no matter who you are, as a citizen of the United States, there's certain conditions that you have to follow. Okay, I wrote a few conditions down on this paper here. You do not need to write these conditions down, but just think about these for a second. Maybe you've heard this before. You must be 18 or older to enter this establishment. Okay, maybe you've been shooed away from a place because you weren't old enough. You must weigh under 250 pounds to ride this ride. Your password must be between 8 to 12 characters. Okay, and the conditions go on and on, right? You know, your speed on the highway must be between whatever it might be, 45 and 70 miles per hour. I mean, right now with COVID, it's you must stand at least 6 feet away from everybody, and your desk in the classroom must be at least 6 feet away. So these are all called conditions. Well, as a mathematician, what we strive to do in math, in the field of math, is we strive to take things that happen in real life and express them mathematically. So the idea is that we want to be able to take any of these conditions and express it mathematically with a mathematical expression or set. And that's exactly what we're going to get into today. So the goal of today, I'm going to introduce you to a notation called interval notation, and it's a way to show conditions. Okay, now I do recommend at this point that you do get out a piece of paper and just make like 4 columns on your paper. This left column here is called condition, and we're going to look at 3 different ways to show a condition, and the new one, of course, the one I'm really going to highlight today, is this called interval notation. All right, so condition number 1. Let's say we have this variable x, and the condition is that x has to be a number between 2 and 9. Okay. So how can we show this condition mathematically? Well, let's actually start with the graph, because I think the graph, this number line is the easiest. If we want to show this condition on a number line, we're going to estimate where the number 2 would be. And I'm going to put an open circle there. And you can write the number 2 underneath it if you want. And I'm going to estimate where the number 9 would be. And I'm going to put an open circle there. And then I'm going to either shade in between the 2 circles, or a lot of times what I do is I draw this little kind of bar between the 2 circles. And this means that the number falls anywhere between the 2 and the 9. Now let's talk about why I used an open circle here. So in this case, an open circle on a number line means that the endpoints are not included. They are excluded. Whereas if I wanted to show endpoints that are included, I would put in a full closed circle. That would mean that the endpoints are included. And let's talk about this word between for a second. Generally, so the word between can depend a lot upon the context, but in a mathematical setting, when you see the word between, that means that you are supposed to exclude the endpoints. The 2 and the 9 are not included in this condition. Okay? And so here's how we show this on a number line. Open circle, open circle. The 2 and the 9 are not included, but everything else between is, okay? The 3, the 4, the 5, the 6, the 7, the 8, as well as all the little decimals that could happen between as well. So like 2.1, 2.2, 2.3. Okay, now how can we show this as an interval? So interval notation, x is a number between 2 and 9. It's going to look like this. It's going to be a 2 comma 9. Okay, we write down our 2 endpoints, the 2 and the 9. And in this case, we're going to surround them with parentheses. Because with interval notation, parentheses means that the endpoints are excluded. Whereas to show if the endpoints are included, we would use what's called square brackets. So in this case, the 2 and the 9 not included, I'm going to use parentheses to show this. Okay? And then using set notation, we kind of got into this yesterday, the previous lesson when we talked about compound inequalities. The compound inequality for this is you actually write 2 less than x less than 9. That means that the number is in between 2 and 9. And then I'm going to actually use my set builder notation that we learned in the previous lesson. This means all values of x such that x is between 2 and 9. Now, with the set notation, what we do is we would use a less than sign or a greater than sign would mean that the endpoints are excluded. Whereas if we want to show that the points are included, we'd actually put a little bar underneath the inequality. And a bar underneath the inequality, that's how you would imply that those endpoints are included. Okay, so now that that first example is done, let's kind of zip through these last 3 examples. So condition number 2, z is a number less than 7 inclusive. This time we are supposed to include the 7. So let's find 7 on our number line. Let's bubble it in. And then less than would mean all the numbers below the 7. So here I'm going to draw an arrow. I can either shade everything to the left of the 7, or I'm just going to draw a little arrow like this. Okay, so this would include the 6, the 5, the 4, the 3, the 2, ... But it would also include all the decimals like 6.9, 6.8, 6.7. Now to show this as an interval, our endpoint on the right over here is going to be the 7. And I'm going to use a square bracket for that 7 to show that it is included. Now you'll notice, though, looking at this graph, this condition does not have an endpoint to the left. We have an arrow to the left to show that this condition goes forever to the left. Now the way we're going to actually show that, if there's no endpoint to the left, we're actually going to put a negative infinity symbol to show that there is no endpoint to the left. It goes forever to the left. And a rule that with infinity symbols, anytime you use an infinity symbol in interval notation, you're always supposed to use a parentheses just kind of by definition. I don't really have any good explanation why that is. That's just what you do. All right. Now over here, the way we're going to write this condition with set notation, here we would just say z. Z is our variable. We'd say z is any number less than or equal to 7. The 7's included. That's why I put the bar. And then let's use our set builder notation. All values of z such that z is any number less than or equal to 7. All right, moving on to example number 3. A is a number between 0, which is not included, and 5, which is included. So here we're going to have one of each. You are allowed to have one of each here. 0, not included. It's going to be an open circle. 5 is included. It's going to be a closed circle. I'm going to go ahead and write the 5 here. Shade everything in between. So this is one of those cases where 5 is a part of this condition. 5 has been invited to the party, so to speak, but 0 is not. Okay, now anything that's slightly above 0 is part of the condition. You could have a 0.1 even in there, but the number 0 itself is not. So here we write our 2 endpoints, 0, 5. 0, not included. 5, you are included. So the interval notation would look like this. Okay, and then to write this as a with set notation, using inequalities, it would look like 0 is less than a is less than or equal to 5. And we're going to use our set builder notation, which says all values of a such that a is a number between 0 and 5. The 5 is included. All right, our last one, p is a number greater than or equal to -2. -2 is included. And then greater than implies everything that's above the -2, everything that's to the right of the -2. So I shade everything to the right of the -2. Now here you'll notice -2, my left endpoint is a -2, but I don't have a right endpoint. My right endpoint goes on forever and ever. Here I'm going to use a positive infinity since it goes to the right. Infinity by definition gets a parentheses. The -2 is included because of the greater than or equal to is what makes that the -2 included. And to write this is with our set notation, so we have this number p that is going to be greater than or equal to -2, and we're going to use our set builder format here. We're going to say all values of p such that p is a number greater than or equal to -2. Now your assignment for this is going to be on Canvas. It's going to show up as a Canvas quiz that you will take. Just to wrap this up though, let's go back to our original conditions. Let's try to apply this to real life. Any of these conditions, like you must be 18 or older to enter this establishment, these conditions could be displayed in any of these three ways. Okay, you know, if I were to write it as set builder notation, I could say all values of A. If A was your age, I could say all values of A such that A is greater than or equal to 18. Okay? Now, since our focus today was really on interval notation, here's what this would look like as an interval. 18, your endpoints would be 18, comma, infinity. You can be any age between 18 and infinity and be able to enter this establishment. And this says that the 18 is included. Now here, so this one, you must weigh under 250 pounds to ride this ride. I guess technically you could say the endpoints are from -infinity to 250. Okay, it says you have to be under 250 pounds, so the 250 is not included. Now we know in reality nobody can weigh a negative amount. So in this case, you know what, we'd actually say from 0 to 250. All right, and the 0, you could kind of argue if the 0 should be included or not. Yeah, I guess I don't know how a person could weigh 0 pounds, so I'm gonna leave the 0 not included and the 250 unincluded. But as long as your weight's between 0 and 250, you can ride this ride. Now here's a case where the word between, you kind of have to look at the context. So in a strictly mathematical setting, we would say the word between always excludes the endpoints, the 8 and the 12. But I'm telling you, in real life, the word between, you really kind of need to read the context. If I was just knowing what I know about passwords, if somebody were to say password between 8 to 12, in the actual context of this problem, I would say, you know what, you're going to include the 8 and the 12. That would be my understanding of the context of this. The 8 and the 12 is probably included. You can make a password with 8 or 12 or anything in between. All right, so best of luck on the assignment. Please contact me if you need any help. Take care.